Hello everyone, I am Senthil. With pleasure, I welcome you all to learn computer science with me. In this video, we will answer the following questions. So what is a number and why do we need it? Why do we have different number system? How do we create a new number system? And how do we convert a value between different number system? So after answering these questions, I will list a few model questions that I have prepared by inspiring from previous year GATE exam questions related to this topic. Let's dive into the topic now. So what is a number? A number is a mathematical value used to count objects, measure things and perform arithmetic operations. We have the following four well-known number systems. The first one is decimal number system, which has 10 symbols. Then we have binary number system, which has 2 symbols. Then we have octal number system, which has 8 symbols. And finally we have hexadecimal number system, which has 16 symbols. By end of this video, you will learn to create a new number system of your choice. As we all know, the decimal number system is used by us in our day-to-day life. So then, why do we have other number system? Isn't decimal adequate? To answer these questions, let's take a problem faced by Alice and Bob. Alice is a boss in a big organization and Bob reports to Alice. The Bob work is to share the total payment received every hour to Alice through SMS. However, today Bob has an issue with his mobile that he cannot type numbers 6, 7, 8 and 9. So he has ordered a new mobile phone, but it will get delivered only tomorrow. In the meantime, Bob needs help from us to convert payment amount represented in decimal number to a number system where there are only 6 symbols, that is 0 to 5. Hence, we need to devise a new number system for Alice and Bob. So before helping Bob, we need to understand the decimal number system. Then we can devise a new number system for Bob. In the decimal number system, we have 10 symbols 0 to 9. After symbol 9, we can continue introducing new symbols to represent counts greater than 9. But then it will become too difficult to remember all symbols and then do arithmetic operation. Hence, a long time ago, our ancestor decided to use only 10 symbols in a decimal number system and then reuse these 10 symbols to represent a larger count. So how do we reuse 0 to 9 to represent count greater than 9? Let's assume these two boxes as 2 slots. Each slot can take a digit from 0 to 9. We define a round as a usage of 0 to 9 in a slot. The leftmost slot would specify how many rounds have been completed entirely in the remaining rightmost slot. So let's see how we can use this method to denote value greater than 9. So we know the first 10 numbers, that is 0 to 9. To represent a value that is greater than 9, we can put 1 0 where the 1 in the leftmost slot denotes that one round of 0 to 9 is over. Then we can easily represent 1 0 to 1 9. And then we need to increase the leftmost slot by 1 to denote 2 rounds of 0 to 9 is over. This method continues on till we reach 99. To go beyond the count 99, we need 3 slots. Again, each slot can take a symbol from 0 to 9. For the leftmost slot, one round denotes 0 0 to 99, total 100 crowns in the remaining 2 slots. The middle slot would specify the number of completed round in the remaining one rightmost slot. Hence, after 99, we will put 1 in the leftmost slot and denote the next greater number, that is 100. When the rightmost slots complete 0 to 9, a round, then the middle slot would be increased by 1. This is why we see 110 after 109. So after 199, we can say another round of 00 to 99 is completed and hence the next greater number is 200. And the same logic will be applied when the number of slot increases when the value is greater than 999, 9999 and 99999 and so on. So by this time, you should have understood how the decimal number system was developed. If not, please rewatch the last few minutes of this video. Let's develop the Alice-Bob number system. For any number system, we can follow the same round concept that we used to devise the decimal system. For example, we would have the following numbers in the Alice-Bob number system. 0 to 5, then 1 0 to denote that one round of 0 to 5 is over. Then it will go on till 15, that is 15. The next number is 20, because we do not have the symbol 6 in the Alice Bob number system. The 2 in 20 denotes that 2 rounds of 0 to 5 are over. So after 55, we have 100 because 1 round of 0 to 55 is over. The method is continued forever to get other numbers. So let's look at equivalent decimal number of some of the Alice Bob number. The first 6 numbers, that is 0 to 5, are the same in both number system. The difference will start when we need to denote a number greater than 5 as shown in this table, because we don't have symbol 6, 7 and 8 in the Alice Bob system. Now that we have developed the Alice Bob number system, we need to help Bob convert the decimal number to the Alice Bob number. On the other hand, we also need to help Alice convert the Alice Bob number to the decimal number. Let's help Alice first. So what does the value 7524 in the decimal system denotes? It denotes 7 rounds of 0002 999 are over plus 5 rounds of 00 to 99 are over plus 2 rounds of 0 to 9 are over plus till symbol 4 has been used out of 0 to 9 in a new round. As a result, the total count would be 7 into 1000 plus 5 into 100 plus 2 into 10 plus 4, which gives us 7524. We can devise a formula for this method as follows. Let's assume A3, A2, A1, A0 is a 4-slot decimal value where each AI takes a symbol from 0 to 9. Let's introduce a new terminology called base B, which denotes the number of symbols in the number system. Then the formula can be written as shown here. We can use this method to convert a value from the Alice Bob system to the decimal system. In fact, we can use this formula to convert a value represented by any number system to decimal. Let's take a value from the Alice Bob system and convert it into the equivalent decimal number. 100 with base 6, which means 1 round of 00 to 55 is over. If we apply our devised formula as shown here, we will get 36 as the equivalent decimal value for the 100 in the Alice Bob number system. As I mentioned earlier, this formula can be used to convert a value in any number system to a decimal number system. Please do the following exercise and post your answer in the comment section. Now we have devised a method for Alice. Alice is thanking us for helping her. Our job is not done yet. Let's help Bob convert a value in the decimal system to the Alice Bob system. Given a decimal value such as 100, Bob mainly needs to identify how many rounds are needed to represent the same value with 6 symbols. This can be done by applying the division rule. The 100 divided by 6 denotes the number of rounds needed to represent the value 100 with 6 symbols and is equal to 16. And the remainder is 4. This is nothing but 16 rounds of 0 to 5 are needed plus till symbol 4 out of 0 to 5 in a round is needed, which can be represented as 164. However, we don't have the symbol 6 in the Alice Bob system. Hence, we need to find the number of rounds needed to represent 16. 16 divided by 6 is equal to 2 and the remainder is 4. This tells 2 rounds of 0 to 5 are needed plus till symbol 4 in a round is needed, which is equal to 24. As a result, 244 is the value in the Alice Bob system for 100 in the decimal system. To make this into a formula, we can do the following. Divide the decimal value V with the base B of the target system. Leave the remainder and divide the quotient if it is greater than or equal to the base of the target system. When the quotient becomes lesser than the base B, write the last quotient followed by the newest to the oldest remainder. Congratulations to us. Now we have helped both Bob and Alice with their problem. So now you can solve the following model questions which I have prepared by inspiring from previous year GATE exam questions. Please post your answer in the comment section. In the next video, I will provide solution to these model questions in details with tips and tricks. How many ones are present in the binary value of the decimal number represented by the following expression? How many ones are present in the binary value of the following decimal number? What is the value of y in this expression? Given that we have 142 in decimal system which has 6 symbol, which is equal to x6y. What are the values of x and y for which this solution hold? There can be more than one x and y. Hence, answer all possible values of x and y. Given that 32x is equal to 1 by 8, what are the possible values of x and y for which this equation is valid? Given that 62x is equal to 32y, what are the possible values of x and y? So what is the hexadecimal equivalent of 121 with base 3? Consider this quadratic equation which has x square minus 15x plus 22 equal to 0, where the coefficient of this equation is in the base b. The above equation is valid when x is equal to 6 or x is equal to 7. When both 6 and 7 are in base b. What is the base b? Thank you for watching this video. Please subscribe to this channel and press the bell icon to never miss any of my lectures.